and welcome back. Today, we're going to go over some molecular formulas, but we need some help from our friend here. Mr. Mole, hey, it's time to wake up. That's right. You have done so well with percent composition and empirical formulas that we're ready to move on to more fun with chemistry math. Hey, Mole Man, nap time's over, buddy. Well, while our friend here comes back to the land of the living, we're going to learn to write molecular formulas as well as learn about hydrates. Lazy mole. Yes.
In this lesson, you will define molecular formula, determine molecular formulas, define hydrate, and determine hydrate formulas.
Now that Mr. Mole is back with us, let's begin a little review from our last lesson. What do we mean by the term empirical formula? Of course, you remember that an empirical formula is a formula that shows the simplest whole number ratio of the elements in a compound. Today, we're going to expand our knowledge to talk about molecular formulas.
The molecular formula of a compound represents the actual number of atoms of each element in the compound. Since the formula for an ionic compound is simply a ratio of the ions in the compound, the empirical formula is all that is needed to represent an ionic compound. However, covalent compounds exist as individual molecules with a certain number of atoms of each element. The empirical formula does not always represent the actual number of atoms of each element in the molecule, so it is necessary to determine the molecular formula as well.
Let's look at a couple of examples to see if we can sort this out. Water is a covalent compound, and we all know that a water molecule is composed of 2 atoms of hydrogen and 1 atom of oxygen. The definition of a molecular formula is that it represents the actual number of atoms of each element in the compound. So the molecular formula for water would be H2O. What about the empirical formula? The simplest ratio here would also be H2O. That's okay. Sometimes the empirical formula and the molecular formula are the same for a covalent compound. But we need the 2 types of formulas because this is not always the case. Take hydrogen peroxide, for example. A molecule of hydrogen peroxide consists of 2 atoms of hydrogen and 2 atoms of oxygen. What would be the molecular formula? H2O2, of course. Now, what would be the empirical formula? The simplest whole number ratio of the atoms would give us HO. In this case, the molecular formula and the empirical formula are different.
If the empirical formula and the molar mass of a compound are known, you can determine the molecular formula. For example, the empirical formula of glucose is CH2O, and the molar mass is 180.0 grams per mole. What is the molecular formula? The first step is to find the molar mass of the empirical formula. In this case, we add 12.0 grams per mole, plus 2 times 1.0 grams per mole, plus 16.0 grams per mole to get 30.0 grams per mole. Next, we compare the molar mass of the molecular formula to the molar mass of the empirical formula. Since they both have the same units, they will cancel out. 180.0 divided by 30.0 is 6.00. So the molecular formula has a molar mass that is 6 times larger than the empirical formula. To find the molecular formula, you simply multiply the empirical formula by 6. This gives us a molecular formula of C6H12O6. Now it's your turn. Work this problem in your notes. Another compound has the same empirical formula as glucose, CH2O, but its molar mass is 240.0 grams per mole. What is the molecular formula?
We already calculated the molar mass of the empirical formula to be 30.0 grams per mole. Again, the units will cancel because they are the same. Since 240.0 divided by 30.0 is 8, I multiply the empirical formula by 8, and my molecular formula is C8H16O8.
Yes, Mr. Mole. My student did very well. What's that? Oh, our friendly neighborhood mole man thinks that you need a little more practice. Your local teacher will pause the tape while you try the following problems. In each problem, you are to determine the molecular formula given the empirical formula and the molar mass.
Local teachers, please pause the tape while your students complete problem set 1.
Let's see how you did. My students are going to guide you through the correct solutions.
The molar mass of CH is 13.0 grams per mole. So I take 26 grams per mole and divide by 13 grams per mole to get 2. Then I multiply CH by 2 to get C2H2.
Perfect!
The molar mass of NO2 is 46 grams per mole. So I divide 230 grams per mole by 46 grams per mole and get 5. This gives me N5O10.
Right again.
C3H8 has a molecular mass of 44 grams per mole. Since that is the same as my molecular mass, the empirical formula is the same as the molecular formula.
Mr. Mole is very impressed. 3 problems and 3 correct solutions. Let's try one more molecular formula problem before we learn about hydrates. 4.04 grams of nitrogen combine with 11.46 grams of oxygen to produce a compound with a molar mass of 108.0 grams per mole. What is the molecular formula of this compound? Oh, wait. I see looks of panic and confusion on your little faces. Just because a problem sounds difficult upon first reading does not mean that you can't do it. Never give up. Just take it one step at a time.
In order to determine the molecular formula, you need to know the molar mass of the empirical formula, as well as the molar mass of the molecule. So the first thing we need to do is find the empirical formula. In order to do that, you need to convert the grams to moles. Do this in your notes. Mr. Mole says, check your work. Now write the formula using the moles as subscripts, and then divide by the smallest subscript to find the simplest whole number ratio. You should have found the formula to be NO2.5. Of course, all subscripts have to be whole numbers, so we multiply by 2 to get the empirical formula to be N2O5. That's just the first step. Remember, the problem is to find the molecular formula. Next, you need to find the molar mass of the empirical formula. Now check your work. Since the molar mass for the empirical formula and the molar mass for the molecule are the same, the molecular formula is N2O5.
You see, if you just take it one step at a time, you can work any problem. Speaking of problems, we have one more type to tackle before we wrap up this unit.